So let's look at our Unit 7 review from InCase that you worked on today in class. The first 10 questions you worked on without a calculator, and then the last 2 questions you did with a calculator. So number 1, it says to find the value of the expression when simplified. So if you could enter with the exponent, you could do 2 times 3, because this is a power of a power, and you could find that it's 4 to the 6th. Now, something that might be beneficial for this is to evaluate what is 4 to the 3rd before you square it. So 4 to the 3rd, 4 times 4 times 4. This is 16 times 4, and then 16 times 4 is 64. This is the value of 4 to the 3rd. But then I've got to square 4 to the 3rd. So I'm going to take 64 and square it. 4 times 4 is 16. Carry 1. 4 times 6 is 24. This is 25. Put your placeholder 0. 6 times 4 is 24. 6 times 6 is 36 plus 2 is 38. Add 4,096 is the value of 4 to the 3rd to the 2nd power. And that's what you would enter there. Number 2, which method or methods will generate an equivalent expression to the one shown in the box? Select all. Okay, so what you might want to do here is work it for yourself the first time. So because they both have negative exponents, you would reciprocal both of these expressions, and you've got 5 to the 2nd over 5 to the 5th. And you could have 1 over 5 to the 3rd. You could do it that way. Or you could say, because I'm dividing, I would subtract negative 5 minus negative 2. Say that that is 5 to the negative 3rd, and then reciprocal that. You got 1 over 5 to the 3rd. 2 different methods, you're getting the same thing. So A says keep the same base, subtract negative 2 from negative 5, and get 5 to the negative 3rd. We did that. And then they evaluated 5 to the negative 3rd is 1 over 125. So this is correct. If you evaluate 5 times 5 times 5, it's 25 times 5, and you multiply that, that is 125. So we could have 1 over 125 here. So A is one that we would select. B, keep the same base, add 5 to negative 2 to get 5 to the 3rd, and 5 to the 3rd is 125. This is not correct because we should have 1 over 125. What they've done with C, would we end up with 5 to the 3rd as the denominator? So if I go back to my first method up here at the top, 5 to the 2nd, when I use the reciprocal for the negative exponents, I ended up with 5 to the 2nd in the numerator and 5 to the 5th in the denominator. Now if I stretched that out, I would get C. 5 to the 2nd here and 5 to the 5th there. So I would also pick C. D is not correct. It's going to give me the whole number 5 to the 3rd, 125, if I evaluated it. So I'm not going to pick D. All right, number 3. When comparing the ratio of 9 to the 2nd to 9 to the 7th. So I'm going to go ahead and write that as a ratio. A ratio looks like the fraction. It's comparing two things by dividing. Luciano calculated that as 1 over 9 to the 5th. Is Luciano correct? Why or why not? All right. So here going to get rid of C and D because we're not multiplying. Okay, so those are poor answer choices for that reason. Then with A and B, there are two ways you could look at it. You could say, if I stretch this out, squeeze another one in there. These two knock each other out. We'll have a 1 on the top, and then we've got 5 9s on the bottom. You could do it that way, or you could say quotient rule 9 to the second minus the 7th, because we're dividing same bases. We can subtract the exponents. That's the shortcut. And then they ended up with 9 to the negative 5th. Then you use the reciprocal and end up with 1 over 9 to the 5th, which would be A. Next, for number 4, we've got 2/3 to the negative 2 times 3 times 2/3 to the third. So what I'm going to do here is deal with this negative bit. That means I'm going to reciprocal this 3/2, and it'll be squared. And then I've got times 3, so if you like, I would recommend, if you're multiplying by a whole number, go ahead and put the 1 underneath that. And then we're multiplying that by 2/3 cubed. Now something that I notice here is that if I multiply 3/2 by 2/3, that will make 1. And if I multiply another 3/2 times 2/3, that makes 1. So I'm going to simplify this down here. We get 3 divided by 1, or 3 wholes, times 2/3. If you want to multiply top times top, bottom times bottom, you got 6 divided by 3, which is 2. For number 5, if the expression 52 millionths is written in the form of 5 2/10 times 10 to what power, what would be the value of n? So 52 millionths. I'm going to take that fraction and write it as a decimal. So this is the ones place value, so there's a 0 there. This is the tenths, hundredths, thousandths, 10,000ths, 100,000ths. This is the millionths. Okay, this is million right here, so I'm going to stop at millionths. The 2 goes in that place. The 5 goes in front of it. And then all these places in between are zeros. Now I'm going to take that and write it in scientific notation. How many times did that decimal move to go from between the 5 and the 2 to over here, where it belongs, to be equal to 52 millionths? And that would be an exponent of negative 5. Now, I will say that I personally found this next question to be a pretty tricky question. So the thickness of a dime is approximately 300,000 times larger than the thickness of a grain of pollen. The dime is thicker than the pollen, which is sensible, right? The most reasonable measure for the thickness of a grain of pollen is how many meters. So first thing, I want you to take note of meters. So let's get rid of some poor answer choices here. So if I take these and write them in standard notation, this one is going to be 7 zeros and a 3. This one's going to be 2 decimals and a 3. This one's going to be 3 with 3 zeros. And this one's going to be 3 with 8 zeros. 5, 6, 7, 8. Okay, and if we're talking in terms of meters is like the length of a yard, almost. So 3,000 meters or 3,000 yards, no way is pollen that big. That would be terrifying. Same thing with 300 million. Like, it's not going to be that big either. That would also be frightening. Okay, so we're down to these two. Now, the thing that I found particularly tricky about this question is that if I took this and wrote it in scientific notation, it would be 3 times 10 to the positive 5th. But because it gives us the thickness of a dime, and we've got to go thinking about that the pollen is going to be smaller than that, we're actually going to go smaller. And because of that, what is going to be smaller than 3 times 10 to the negative 5th? There's only one that's going to be smaller than that, and that is going to be 3 times 10 to the negative 8. If you're talking about from end zone to end zone, it would be about 100 yards. But if we include the end zone, that would be 120 yards. Okay, now a meter and a yard, they're roughly the same. Remind me tomorrow. And I will show you a meter stick. Okay, and I think I have a yardstick, and I can show you the difference between them. So the best approximation for the length of a football field, well, this one was just 1.05, 1 meter. No, that's a terrible choice. This one, if I move that decimal 2 times, is 105 meters. This would be super gigantic. Okay, what is this number? 105 million meters long. And then this one is even bigger. A billion. So the one that we would pick there is the one that's pretty close to the green numbers that I have over here on the right. I would choose B for that one. 1.8 is going to be our leading factor here. So look right here. Told you they'd give you bad answer choices with the leading factor being not in scientific notation, not a number between 1 and 10. Right there, right off the bat, get rid of C and D. Not in scientific notation. Next, look at what this is. This is a gigantic whole number. From that alone, you should be able to know A is a terrible choice right there. We've got a negative exponent. We're not going to pick that guy. So just from using reasoning skills, we can pick out the correct answer there. Number 9, place these values in order from least to greatest. Grab each expression and drag it up or down. Okay, we can't do that, but we can state which one's the least and which one's the largest. Or we can put it in order of 1, 2, 3, 4. 1 being the least, 4 being the greatest. Okay? Now, I told you guys to look at the exponents first. Greatest. Which one has the biggest exponent? That'd be this one. Next, I would go ahead and put this one. Now, keep in mind that negative exponents are going to make it actually a smaller decimal. So this one is the least, and this one is the next. Number 10, a student calculated 2.0565 divided by 45 using her calculator. I'm going to go ahead and tell you that when you do that, this is what you get. Okay, so this is 457 hundreds, thousandths, 10 thousandths. So if I wrote it as a fraction, 457 10 thousandths. That's what that looks like. Okay, so now we got to pick, and it says select all that apply what could be on the display for the calculator. So I know that you see that D is equal to that, what we have there. E is not equal to it. C is. So we've got C and D, and there's one more. And I talked to a couple of the classes on Friday about this. So I want to tell you that if it says a big E, capital uppercase E, is for a base of 10, and the number that follows that big E is the exponent for that base 10. Okay, so there's one that is equal, one more. So I will tell you this. The little baby lowercase e is not it. Okay, so we're not picking that one because that means something else entirely. So don't pick little e to the -2. You're going to pick uppercase. So now we're getting to the part where we got to use the calculator. So this is a scientific notation problem. So the distance from Earth to Sun is approximately 1.5 times 10 to the 8th power. The approximate distance from Earth to Jupiter is 8 times 10 to the 8th power kilometers, and the approximate distance from Earth to the Moon is 400,000 kilometers. So we've got some numbers in scientific notation form, and then we have other numbers in just standard notation. So we are going to take the Earth to Jupiter distance is how many times the Earth to Moon distance. So first of all, what am I going to be putting into my calculator? Earth to Jupiter is this number right here. 8. And I really don't need this decimal zero, so I'm just going to put 8 times 10 to the 8th. And to figure out how many times, I'm going to actually divide. So Earth to Moon, we're looking for Earth to Moon is 400,000. I'm going to divide by 400,000. So go grab your calculator. Here we go. Parentheses. 8 times 10 to the 8th power, close my parentheses, divide by 400,000. And there we go. It's 10,000. 2,000 I said. So 2,000 is the how many times the distance is. Alright, match each value in scientific notation with the expression described. So personally, I would find it easier to deal with the multiplication problems. I think I could type those in faster to my calculator because everything's just a multiply. So I really don't even have to worry with those parentheses since everything's a multiply. You can multiply in any order and it doesn't matter. Commutative property of multiplication. So for this one, the one that belongs with that is 3 6400ths times 10 to the 6th. Now if you look right here, 10 to the 4th and 10 to the 2nd, ooh, we ended up with 10 to the 6th. Look at that. Alright, again, same thing here. We end up with 9 1500ths when we multiply those times 10 to the, what do you think? 12th. Alright, now to do the divisions. 1.3 times 10 to the 4th divided by the 2.8 times 10 to the 2nd. Okay, sometimes we end up with a number that is not in scientific notation already. So if I put in 1.3 times 10 to the, I forgot what my exponent was, fourth, close that parentheses, and divide it by 2.8 times 10 to the second, close my parentheses. So there it is. I've put it into this calculator, push enter. Okay, I get this number right here. Alright, so I got 46 and a whole bunch of stuff. So 46. Now that's not in scientific notation. So if I put it in scientific notation, it was a whole number, multiply it by 10 to get there. So that one goes here, 4.6 times 10 to the first, but we don't write that. 4.16 times 10 to the 8th, close my parentheses, divide by 2.2, I forgot them again. Gotta remember the parentheses, goodness. 2.2 times 10 to the 4th, close it, push enter. Alright, so I got this 18,909 number. Change my color. 18,909. Put that in scientific notation, or you could just look for what's the only one that has these leading numbers, and then that's what the one you would pick. And that fits this one. Alrighty. And that is all I have for today. Thanks for watching. Make sure you save the numbers that you would like to ask me questions about, and we can hopefully talk about them real quick tomorrow if there's an explanation that you need further details on. Thanks for watching. See you tomorrow.